Hello, hello. This is a second attempt at Puzzle P. I misunderstood one of how the snakes work, so this is a second go at it. So, normal Sudoku, we're drawing a couple of snakes that start and end on these points. One, and they can't, and one is a. How's it gone? I should have read the rules before. Well, I've just worked out what I was missing the first time round. There's a rule that I completely forgot. So one snake's a Dutch Whisper, and one snake's a 10-line. They can't overlap or anything. The rest of the clues are falling out the grid with standard gravity rules. They can't pass through each other, but they can pass through these. The rule I missed is each snake may contain no more than 3 different low digits selected from 1, 2, 3, and 4. That's going to make a big difference. Hopefully. Because otherwise I cannot see how to solve this puzzle. I think that is everything else though, isn't it? Normal region, killer arrow. Yeah. So I've got one cat that's trying to sleep next to me and the other cat that's just in full mental mode, and I'm trying to keep the peace. I might get distracted sometimes. Oh. So. Right, what I want to do is have a bit of a think straight away at what the what the 10 line looks like. So if you had 9 nines, you'd need 9 ones. That doesn't work. If you have 8 eights, you'd need 8 twos, or 8 things from 1 twos. That doesn't work. If you had 7 sevens, you'd need 7 things from at least 7 ways to make 3, which you can't. If you had 6 sixes, that looks like that could work with some 4s and the such. And I'll just fill in this as well quickly. Not that. Oops. 1, 2, 4, 5. I don't think it helps much yet. But there's interesting things about the 4s. Because there's definitely a 4 in one of these two, because they're of different makeup. So this is my 10 line, which can come from these digits. So in fact, I think so wait, sorry, if you had 6s, you then have to have so that's not what I want to do. Try and do that. If you had 6s, you have to have 10 ways of making 6. But what about that? That actually seems okay straight away. I think I need to think about the entropic line. The entropic line, the Dutch Whisper. 6, 7, 8, 9. So it's the easiest way to think about this. If you had 6 sixes, just move you to there and then type down there. There we go. You had 6 sixes, then in between each of them, you could only get these sort of digits, couldn't you? And then you've got a bunch of extra 6s left over, so 6s don't work. You try to have 9 nines. 7, 8, 9. Can't immediately see something wrong with that. If you had 5 5s, then yeah, maybe I do need to think about the 10 line more first. Because one of the interesting things is, because you've got 2 given 4s in the grid, only one of these is allowed to use a 4. So can I disprove something like the 10 line? Does the 10 line always need 4s? I think probably. So let's go back to the 10 line. Time being. So if the 10 line didn't have 4s, it wouldn't be allowed 6s. It's the only way, because you can't do 6 1 3 6 2 2. That's the only other way. So you're left with these digits. And if you didn't have 5s at that point, you'd be saying that. So I'm trying to prove that there has to be a 4 in this 10 line. If you didn't have 5s, you couldn't be 3 3 3 1 just because of how that works. So you'd need a whole bunch of 5s, making things sum to 10. So what's wrong with this setup? Because if you did have the 3, because from these, you can get the sums of 1. I'm thinking about totals, 9, 25. So to get 10, you could be 1 3, which doesn't work. So you'd have to be all of those. So can I disprove this? Because then the 10 line would need a 4, which would be nice. Is it just trivial from how these are set up? Yeah, because you'd need 5. No, because you'd need 5 5s, but that would have to cover a grid. Like you'd have to go. You'd need. And that's 5 as well, isn't it? Is this the way to go? Or maybe it's interesting to say. Yeah, it's possibly interesting to say, if you were this sort of setup, does that then hurt your Dutch whisper? Given I can't immediately see a trivial way to disprove this. Although what am I trying to do? Trying to make a 10 line using these digits. You've got quite a lot of length. Get places. Seems okay. So maybe the Dutch whisper. I mean, yeah, here's a thought. Going back to the Dutch whisper. It's going to be an easier way to do that. There we go. I can flick back to this. Perfect. Easy way to think about the Dutch Whisper is how many of 7, 8, and 9 are you allowed? Because you're not allowed. Can you have 7s? No, you can't have 7s and 8s. So out of small, including 5 digits, you can have at most 14 because you're not allowed all of 1, 2, 3, 4. Contains no more than 3 different low digits. And 7 and 8 won't work because then you'd lose the 5. So, and you've got to have at least one of those. So you're going to have exactly one of those big digits. And so let's think about 8s maybe. 1, 2, 3, 4, 5, 6, 7, 8. Even put extra spaces. Possibly. And I mean, you could spill out on the edge as well. I'm from what I did before, I'm pretty sure that 7 is the thing, so I'm trying to disprove the other 2 at the moment. Possibly isn't the best way to think about it, but and so that's if you don't have a 4, have to look like this. I'm pretty convinced he does need a 4. The 10 line. But I can't see anything. See. Immediately wrong with that. You can't have a 9 because you've already taken the 9 out from the clue, of course. So 9 isn't one that's allowed. So now I've just got to disprove 8. So we, and if you are 7 7s, 6 7, then the only way that works is with 1 2s and 3s in between, isn't it? Let's just get rid of all the 7. So 7 1 7. 1 2 3 4 5 6. That would be the only way that 7 works. Sorry, I just had to go deal with some stuff. So, where was I? I was saying that this is entirely possible and I think very likely for 7s. You obviously can't have a 5 in this thing at all. And if you did have 8s, right? If you did have 8s, you'd have to have 4s. And 3s? No, you could go like that, couldn't you? So the only thing to note is if there is 8s, there's definitely 4s. So can I go back and try and disprove this? Why would this not work? The 10 lines. Just going to double check the rules, check that I haven't seen anything else incorrect. Don't think so. I mean, that given 5 would line up with this, but does that help you disprove this at all? I don't think so. What are your other options? If you did have a 6, you'd have to be 6 4 6 4 6 4 6 4 6 2 2. And if you didn't have either 5 or 6, you can't be 3 3s and a 1. UB4s, 3s, and 1s probably. 6 4 6 4 6 2 2. I want to go back to trying to disprove this in order to make sure this has got a 7 in it. Especially because 7s are then so forced with how they all work. The annoying thing with 8s is it doesn't have to start and end with an 8, does it? These could be 3s and then it could have a 1 sticking out the end. I think, anyway, pretty sure, yeah. Eights don't just clash with the other clues, no. Bunch of 5s. 2 2s and a 1. What on earth is wrong with that? Why can I not see that breaking? Oh, isn't it? Is it something to do with how far you'd have to reach if you were these bunch of 8s? Is that interesting? So, if you are this case where you've got to fit a whole bunch of 8s in here, you'd have to be able to reach a new box after every 8. And so if that was 8, you could only get into this box, couldn't you? Might be an easy way to prove this, but because that's not an end point and it can't reach an end point. Knowingly, that could be 8 if the line did something like that. Because as soon as I can block an 8 out of something else, say, yeah, this cell can't be 8. Because again, you'd only be able to get to there or there. This cell be 8. No, you can only get into this box. This cell be 8. No, you could only get into that box. Annoyingly, this one works quite well because it can get stopped here. Although if this cell was 8, then it could only go into here. Do something like that. The problem is, right, at some point you're going to be pushed to this bottom bit. Yeah. At some point you'll be, and that's probably the same up here. Which one's easier to do? I'll do this one first. At some point you'll be pushed to the bottom bit. This can't be 8. You can't escape. You can't escape on both sides. Yeah, because, oh no, you can go like that. What am I on about? That can't be 8 though, because you could only get into this box. That can't be 8, only get into this box. This can't be 8, only get into that box. In 2 steps, yeah. You can only get into this box. So this would have to be 8, and I bet it's the same up here, isn't it? If that's 8, you can only get into this box. That 8 only get into this box. And then that's exactly the same over here. And then both of these would be 8s and that breaks. Okay. So that's good because we know our Dutch whisper has to now look like 7-1, 7-2, 7-2, 7-3s like this. And that's useful because Certainly useful. Why would it be useful? So you start and end on a 7. That's helpful. And there's going to be very few ways to actually get around, isn't there? So you can do the exact same thing of the only places in these two that could be 7s would be that middle digit. That's the same for this, but these... No, because they stop. We now know they definitely stop and hit a 7. So, like, that cell can't be 7, because it could only... Oh, no, that cell can. This one can't be a 7, because you can only get into this box. You'd have to have another couple of 7s in there. That's the same for here, same for here. Cool. The grid's entirely symmetrical, so I can fill out all of that. So, does that mean... So we've lost one column, and we've lost one row? No, I think you don't have to be in those, do you? Oh, here's a weird thought. And of course, sevens are X-winged. So you can fill all that out. So if this was 7, the only way that works is something like this, and then that obviously breaks. So these cells can't be 7. The interesting thing about that is you definitely have 1 7 here or here, and it can't be here because of these two. So that is a 7. And one of these two, so he goes something like this, which pinks all of that and this. And I think at this point, I'm just going to choose one of these options because it's entirely symmetrical, and then I'll think about that, what it's actually doing afterwards. So he's going to go something to there. He can either go to here or here. If he did go to here, he'd then only be allowed to there or there. That's definitely a 7. Where's this guy going? He can only get to here. No, I've broken that, haven't I? What have I done? No, because you don't need one. You need one in every column. It's the point. You don't need one in every box. But I think what I've said is fine so far. Then this guy could only get to there. This guy could only get to there. So that would have to be 7. And that all works. Now, I'm pretty sure, because I remember doing this from before, that and where let's make all those blue. So where could this line, and where does this line have to go? It's an interesting question, because they're all from 1, 2, and 3. And I seem to remember there being some interaction of, if this was flipped 180, then these had some problems with that. Of course, yeah, you strictly can't take that, and that's the same symmetrically. So that would be 1, 2, or 3 there. So, and this can't be 6 and 7 anymore, either way round. If I was now trying to force this on this side, Is that such a problem? It's probably easier if I drew this the other way around, and then I could actually think about where they all go. And our 10 line, I don't think, or it might be, currently affected by this. I can't see how at the moment. That's one option for the 10 line, obviously, not all of them. That's if it had a 5, I think. There's not other ways to make that work with a 5, is there? Oh no, this was if it didn't have a 4, wasn't it? Yeah. Which actually isn't all that useful. I'll get rid of that for the time being. Come on. Why? So if this was the wrong way round, then up and down here you'd have 1, 2, 3, 4, and that would push 5 or 6 onto the 10 line. But at the moment, I haven't disproved that that doesn't work yet. So do I want to try that? Because that's probably, I'm pretty sure that's how I got the orientation of this. I was saying that this had to be small and then ran out of space for the rest of these small digits. So I think at the moment I want to be thinking about the 10 line. Trying to disprove that if you did have a 6, wait, why? Yeah, 6. Oh yeah, 6. 6 just straight up doesn't work, does it? Yeah. Silly. 6 doesn't work. So if I think about all the square numbers, let's try that again. 9, 16, 25. So you're not allowed just 1, 2, 3, 4 because of the rule that I forgot. Which I think is going to be what changes this puzzle working or not. And what's wrong with there being a 5? I mean, if there is a 5, then 5, 4, 4, and 3. So those two, no. What's the total sum of that? Is 30, 55, isn't it? So if you definitely have 5s, is literally... Are you allowed 5, 2, 3? Hang on, how did I get 5s to work? Oh, it was a 2 2s and a 1, wasn't it? But I think they're given 5. No, because we can't use that given 5 yet. Oh, I'm getting confused now. Very confused. So, if you are using the 5s, are you allowed to use 4 4s as well? You're currently at 41. So you'd have to use the 4s and 3s, and that doesn't work. So if you're using the 5s, you can't use the 4s. Are you allowed to use the 3s? Be at 34. No, because that, yeah. So the only way this does work is like this. And the only way, yeah, I thought I almost had it. 5 5 5 5 5 2 2 1. So if I assumed that we were the other way round, like, sorry, because this isn't going to be particularly easy to visualize, but if this is all flipped, then you get a 1 2 3 4 quad in here, and that would, in this case, have to be one of these 5s. What is wrong with this? Is it ignoring? Because at least one of these does start 5 5. Let's try and disprove one of them. Or if they both started 5 5, this one would have to come up here. This one could either go to there or to there. And where are you getting your other 5s from? The moment you can jump back down. I think there's an easy way to see this, and I'm just not at the moment. I want to do the whole thing of, again, colouring cells that couldn't be 5s. To fit 5 5s. Gotta look like this. If you came up, let me have a quick read of the rules. They may touch and cross each other or themselves. Was it? So if you do have these 5s and with the right orientation, that could never be 5. That would have to be. And if you're the wrong orientation, you get this 1 2 3 4 quads, and that would be 5 anyway. So in this case, I know that would have to be 5. If yeah, I think I can disprove this. No, because this. Yeah, because what I want to say now is if this is 5 5, whatever the next one is, couldn't be 5 5, could it? So the next one can't be another 5 5, no matter what. So out of the first two sums to 10 that originate from this, one of them is the 5 2 2 1. And that would imply that this had to be 5, 5 as well. So put a 5 either there or there. So if this one was 5, 5, he'd have to go up here. And then he'd have to go 1, 2, and then find another 5, which he isn't finding anytime soon. So this one would have to be the 5, 1, 2, 2, implying that this one had to go 5, 5, 5, 5. Isn't that? Yeah. So you can never have four 5s in a row that are all in different boxes. Rows and columns, but all connected. That's the point. Yeah. Okay. Right. I think I'm happy I've disproved that you can have a 5 from these. And what's nice about that is it makes these from 1, 2, 3, 4. And now we definitely do have the right orientation of pink. And I can start properly thinking about how these interact with it all. Because of not having enough 1, 2, 3, 4s there. So this guy can't be 2, 4. For a similar reason, that's got to be a 1, 5. Get a 2, 3, 4, which I need to be careful that that doesn't interact with this and doesn't particularly. Well, but the 1s are gone, aren't they? Yeah, 1s are gone from there. Now, can you literally just go 3? No, you can't be just 3s and 1s. You can't be just 3s and 1s. Can't be. What are you allowed to be? You're allowed to be 4, 4, 2, 4, 4, 2. In fact, that looks quite likely. You can't go 1, 2, 3, 4. If you did have 3s, I've said that you can't be 3 and 1. So you'd have to be everything. That's the only other way that works. So you definitely don't have 3s. So, yeah. So you've got to go 4, 4, 2, 4, 4, 2. That's weird. It's very weird. I'm pretty sure that's true. So we've got this as our 2 things, and these come from 2 and 4. Got to go 4, 4, 2, 4, 4, 2. We've got 4 4s to place, and you're only traveling 6, aren't you? So if you try to go up here, 1, 2, 3, 4, yeah. Not getting anywhere up here anytime soon. 3, 4, 1, 2, 3. And you can only ever take 2 cells in each box. Something interesting as well. See me, you can't get around anywhere like there. There you can. 2 in each box and 2 in each row and 2 in each column as well. That's strange. That is rare. Oh, okay. And this guy at some point will have to enter this again. So you're only doing that once because of the hole. And so you'll definitely have a blue 2 up and down there. Well, this puzzle's definitely easier when you read the rule about having no more than 3 different low digits. He's definitely got at least 1 into this column. That's not necessarily true for that because... Why is it true this... Oh, because this guy can't immediately turn right. That's why. Yeah. And you're going to take up at least 4 columns. Possibly exactly 4 columns. You've only got sort of like 1 degree of freedom, really, don't you? Can't take that cell. You can't come down. Yeah, that's far too much. Oops. Can't get all the way over here. Can get to there. No. Can't get to here. Can't get to here. 1, 2, 3, 4, 5, 6. So that sort of thing would be allowed. But that wasn't because it's in the middle of stuff, isn't it? Yeah. 1, 2. Can't get to there. One, 2, 3, 4, 5. Yeah. And yeah. I have to say both of those, and that just breaks. Don't forget, these 4s are going to be messing with you. And we've taken 2s and 4s out here, so that's not 2 or 3. And you get a 2, 4 pair, so that is a 3. So 2s and 4s. 2s and 4s. So if you're there, you have to take that, this. Those would both be 4s, then 2, 4, 4, 2. I think that works, doesn't it? Yeah. If you immediately came down, right, then you couldn't go left, and then you'd have to go that way, and then that just breaks, because there isn't enough space. You have to come into here. You don't go up. Whoops, that should have been green, shouldn't it? If you were 2, you then have to have 2 4s in a row. Then you could be 4, 2, 4, 4, 2, 4, 4. Seems okay. You definitely take at least 2 in this column as well. So that's the 2, 4, 2, 4. That's definitely a 4. And you don't take anything, any of these. So you don't take any of those. And now that's got to be your other 4, doesn't it? Weird. With a 2 there, with a 4 there, a 2 there. And it's got to look like that. I'm pretty sure I have now looked at all the possibilities. Okay. Right. Good. Cool. Very weird, but good. This is definitely a 2, 3. Means that's a 1. Gets rid of 1s from there. Definitely have a 2 up here. 1, 2 down there. 7s. What else do I want to have a look at? Our 1, 5 now, look, has to go up here. And this 5 could go there or there. So if the 5 is there or there, then this 3, 2 goes somewhere here or here, doesn't it? Yeah. And I'm saying these can't be 5s is the point. 5 is there or there. Very good. What can this be? 6, 8, or 9? Ah, big. I want it to be big. These are 3s, look, so that's definitely a 2 there. I don't know the orientation down here. I don't think, anyway. There's a 4. 4s are up here. So that's not all the way up there, but sure. 7s is all the way down here. Is that our last 7? There's another one, isn't there? Yeah. This guy isn't a 4. He's definitely a 5, 8. He sits somewhere inside all this stuff. Could that guy party up there? No. So this line has gonna have very few possibilities, isn't it? I'm pretty sure. Not allowed there. Whoops. Not allowed here. Not allowed there. It's one option. That's literally the only option. So he's not allowed down there. Crazy. And I've broken the puzzle. So he's a 9 with a 1, 3, 5. Certainly not 5. 5 and 8s are there. These are 5s. That's got to be 5 and 8 like that. 9 and 6. 5, 1, 3, 5. Good. 1, 3. No, that's a 3. With a 1, 9 pair. 5, 1. Change that to a blue line. Easier. So, don't really need lines on here. Yeah, that's fine. I'll get rid of all those. Make it easier. These cells, that's a 3, 5s. That's a 6, 8 with a 2, 3, 9, a 1, 6, 8. 8 and 5 is done. One of these is a 2, 3 looking at 9. So helpful. Are given 4. Random given 4 somewhere. Seems okay. 5s are here. Else haven't I placed this? So if that was 5, right? That would have to go 1, 8, 9. That seems okay. Where can this guy go? He's either there or there, isn't he? And either which way he's 1, 8 with a 9. Yeah. So 9s are somewhere there. Oh, the 5. 5 has got to go here. So that's that 5 done. 5's there. 5 are 2, 3. Along here, 3, 4, 8. Yeah. In 8 as well. 2, 6, 9. Oh, 6, 6, 8, 9 now. That's definitely 2, and that's a 6, 8, 9 triple. 1 there. 6 and 9. 6. I mark those. Nah, that's fine. 2s and 3s and 9s. That's 2, 3. Or if that's 9. Yeah, that works with 2, 3, doesn't it? Yeah. I was trying to see if they interact in some way that stops that, but that's not true. 2, 8. So this is definitely a 1, 8, 9. That. This is a 2 and a 3. Somehow. We've got a given 4, which can't go down here because of the arrow. The given 4 is there. This arrow might be interesting at some point. This given 4, do you think he's going to have to? I mean, he can't be part of that. So that can't go 4 and 1. Happily go 4 and 1 like that. It's at the top. So if that was 1 and 4, then the other one, this would have to be a 2, 3. That seems okay. These two cells are known. These are 2 and 6. 8, 9. 9, 9, not 1. Oh, there's something strange with a 9. 9, 1, 8. Ah, no, that seems okay. 9, 1, 8. It's 1 and 8, yeah. I suppose one of those two is always 9. Because it's always 8, sorry. Because otherwise you're 8, 9, and then 8. Yeah. That probably made no sense. 4's down here. Oh, one of these has to be a full one. Is that the point? Yeah, so either that's 4-1 like that. That's 4-1 like this. One of those two is a 1. And where is this guy sitting? Can't sit there. He could sit there. Or he sits right at the top if he is a 2-3. Here's a 2-3. That goes for 1. So that can't be 4 and 1. No, wait, hang on, what? That can't go 4 and 2. Yeah, because then that would have to be a 2-3. Oh, this is a 4. There we go. So this is our other 2-3. And they just make a 2-3 pair. What's happening there? Not sure, actually. 5s, 9s helping us out. What haven't I placed in the grid? It's all done. I think that's basically done, but I'll come back to it if not. We've got this 2-3 going on. 6, 8, 9's happy. Is it going to be the arrow? Feels weird if it was the arrow. Where could the arrow go? That seems fine. That seems to not work. That seems to not work. That seems fine with a 3, 6, 9. So wait, what was this? This would be only work. Oh, hang on. The 7, 2, 5, 6. Or you're down here with a with a 9, 6, 3. Or could you be right at the bottom? You'd need to be a 6, 2, 3, 8, 9. I think that would be another possibility. Like that. Oh, sorry, this being trapped by the 9. I think that's the point, isn't it? So he's trapped by the 9. Can't go there, so he is in this box, and he's not a 2-3 pair. That is 1 and 4. It's a 2-3, which has to go at the top. 6 and 9. Then that's still holding out, isn't it? So this couldn't be. Yeah, that could still be 6, 2, 3, 8, 9. That's 2-3 is done. That gives you this stuff. So that's pink. 5, 1. 9, 8, 8, 6. That could still be 6 if it was that one. 2, 3, 4, 5, 6, 7. It's just straight up a 2-3 pair. Where's the end? This is 2-3. Makes that 2 or 3. I suppose if you were this very bottom arrow, then, because that would be from 2 or 3, that would be 2, 3, 9. So that would have to be an 8. So it only works with a 2 there, but seems okay. This is 5 and 1 and 9 and 8. Oh, 1s, 8s, 9s. There we go. 6, 8, 3, 2, 6, 9 there. So you have 5, 6, 8, 9 here. So neither of these are the arrow. Lovely. 52919. 2 1 8 1 and 8. 8's down here. And finally, to finish off, 6 and 5. Done. Very good indeed. Yeah. I mean, I just I can let you know it's a hell of a lot harder to solve if the digits, if you don't read the rule about the 3 different low digits. But cool, very good idea, well executed. Just the problem I have is I think I do have an excuse for not reading that because the rules are so long. And it's a bit of a... The trouble is it's a rule that isn't one that sticks in your head and is one that's vital. And I say it doesn't stick in your head because it's sort of a bit of a tacked on thing compared to everything else linking up together, if that makes sense. I don't know if that's just me, but that is the issue I think I have with these sort of puzzles. And it would be nicer to not have that rule and be able to sort stuff out with additional clues or something. Would have been preferable personally. But yeah, fun idea for sure. And it did flow pretty smooth. There were some tricky points. The 5s. I might have just been missing something obvious of why that path didn't work, so apologies for that if that's the case. But anyway, thanks for watching. Hope you enjoyed. Thanks for the puzzle, and chat to you all sometime later. Bye.